Okay, this video is inequalities with two variables. So this is going to look very similar to situations where we have like y equals mx plus b. Okay, or we could use intercept form graphing. But instead of just being a line represents the solutions, we're going to talk about a region or an area that is bounded by a line. Okay, so just like when we did number line where you had open and closed circles, we do the same thing. But an open circle, instead of an open circle on a number line, it's going to be a dashed line. Okay, so we're going to see it something like this. And it means it's not included. So you can get up to the line, but you can't actually touch it. Whereas a solid line is where it's equal to. We saw that as a solid circle and so forth. So that means you can, yes, include a line and actually stand on the line. So what we have here is the shading, the region that goes up to the line is the actual answer. So that the key is to understand that the shaded area is the answer. Not so much the line, but the shading, okay? Now the thing is, how do we tell what side to shade? We test a point. So we pick a random point on the graph, plug it into the equation, and test, is it a solution or not? Does it give a true answer or false answer? And then that tells us that's the area that we shade around, okay? Typically, we like to use 0, 0 because it's easy, but it doesn't always work. So let's take a look at some examples here to better show how this comes together. So we want to graph, for instance, this equation here. So imagine that the inequality is like an equal sign. So again, we want to see y by itself. So let's establish what's the slope, okay? So if I put a slope in, it's the 1, and I could write it as a fraction, 1 over 1. And what's the intercept? 0, comma 6. And we see that from these two pieces here, the value in front of x and the b by itself. Okay, so let's go ahead and graph the line. Now, the first thing we have to do is establish, is it a solid or a dashed line? So what we're going to look at is the inequality included or not? Being that there's no line here, we're going to say it's not included, therefore it's dashed. So I'm going to start at 6, 1, 2, 3, 4, 5, 6, and we're going to do a graph of slope of 1 over 1. Okay, so I'm going to put a series of dots of 1 over 1. I'm putting them in both directions here, so let's see what's going on. Now, instead of a solid line, I'm going to put in a dashed line. Okay. And again, it continues forever. But that's not the answer. That just gives a boundary. So the question is, do I shade on this side of the fence or this side of the fence? So let's go ahead and test a point. I'm going to test 0, comma 0. And again, because it's easy. So I'm going to literally rewrite the equation. And I'm going to plug 0 in for x and y. Okay. So we're going to plug 0 in here. 0 in here. So this, we're testing this point. Is that point, do I shade this side where the green dot is, or do I shade the other side of the fence? So let's plug it in. 0 is the only thing on that side of the equation. 0 plus 6 is 6. Now we have to look, is 0 bigger than 6? I'm going to say no. So is this a solution? No. So we do not shade this side, but we shade the other side. So the answer is anywhere over here. I can pick any point over here and it will work out. For instance, let's just pick a random point. I'm going to pick this point right here. Okay, and that point is 2, 4, 6, 8, negative 8, comma 3. And it should test out. So let's go ahead and test it in. So we're going to do the y value is 3. The x value is negative 8 plus 6. Okay, so is 3 bigger than negative 2? And the answer is yes. So notice that point is included, and it's in the correct side. Okay, and we can see that in a better example here. So let's go ahead and graph this line. Now the first thing I'm going to do is put it into y equals mx plus b form. So I'm going to divide everything by negative 4. And let's go right over here. Y. Now notice we divided by a negative, so I have to switch the sign. So I'm going to highlight there because divided by a negative. And we're going to have 16 divided by negative 4 is negative 4 over 1x. Okay, so there's my slope. Now notice there is no b value. Okay, so my slope is negative 4 over 1. My y-intercept is 0, 0. So there's a point. It is included. Okay, so it's going to be solid because of the line underneath. So my slope is negative 4 over 1. Okay, down 4 over 1. I'm going to go backwards and backwards again. Now I'm going to draw on a solid line. Now the question is, if we test 0, 0, it will prove to be true because it's a solid line. But we don't know what side to graph, the left or the right side. So I'm just going to pick another point. I'm going to pick, doing a different color here, this point right here, 1 comma 1. Again, nice simple numbers, clearly off the line. And I'm going to plug it in. I'm going to do it right here. Negative 4 times 1, 16 times 1. So notice I plug 1, 1, 1 in for x, 1 in for y. So let's take a look here. Um, Whoops, didn't want to do all that. Let me put some of that back. How's this? There we go. That's a little better. And I want to give a little room here so I can show my work. Okay, so that's negative 4 is bigger than, now again, I'm not introducing a negative number here, I'm just evaluating. Is negative 4 bigger than 16? Okay, and we're going to say no, it's not. Okay, so no. So this point is not a solution, so we're going to shade the other side of the line over here. Okay, so anywhere on this side of the line, including the line, is a solution. So I could pick the point, for instance, negative 10 comma 0, and plug it in, so forth. Okay, and we will get a proper value. Okay, so with these, the important thing is side dash or solid, what side of the line to shade, and again, verify that using a test point. Let's go ahead and have you look at, oh, we got one more example here, so let me go through this here. I'm going to test this out. I thought we were done there. So I'm going to move the 5 over because I want to get y by itself. So y is less than or equal to x plus 2. Okay, so let's graph the line. Our slope is 1 over 1. Intercept 0, comma 2. And being that it's line underneath, it's solid. So I'm going to go ahead and graph my line as such. Got some guide points here. Okay. All right, so again, let's go ahead and test 0, 0 because it's nice, clearly off the line. So I'm going to put into the original equation 0 plus 5, is that less than or equal to 0 plus 7? Is 5 less than or equal to 7? Because notice the zeros drop out. And the answer is yes. So yes, I do shade around that point. So I'm going to start at that point and go up to the line, and that's as far as I can go. And then that whole side of the graph is included. And that, the yellow is the answer. So I'm going to put a big note here. You know, the yellow is the answer, okay? The line itself is not. It's the whole region, okay? So looking at that information, I want you to try this example, put it into y equals mx plus b form. And I also want you to try these two examples here where we gave you a graph, and I want you to write in y equals mx plus b form the answer. So you have to establish, you know, is it less than or equal to, is it greater than, the slope, and the b. Okay?